Hello, my name is Tom Thomas, and today I'll be telling you about our project. The goal of our project is to keep Timmy alive. Right now, he is suffering as he is missing the 9 volts he usually needs. In order to save him, we're going to use a solar cell. A solar cell is an electrical device that turns light energy into electrical energy using the photovoltaic effect. Shown on the screen is a diagram of the components of the solar cell. The top layer of the solar cell is glass, which is used to protect everything else. Underneath it is the anti-reflection layer. The anti-reflection layer is blue and transparent as it has to let light through while also trapping it. Without it, about 30% more light will be lost, as light is already lost due to it being transferred into thermal energy and some of it still being reflected. Underneath it is the silver metal grid, and underneath that is an important layer, the N-type layer. The N-type layer contains phosphorus and silicon atoms, and the phosphorus atoms contain an extra electron. The P-type layer contains boron and silicon atoms. The boron atoms are missing an electron, as they have a shared pair of 7, which is missing 1 compared to the rule of octet. The bottom layer is an aluminum metal plate. The two most important layers is the N-type layer and the P-type layer. As light filters through the glass and anti-reflection layer, it hits the silicon atoms in the N-type layer. The silicon atoms become excited, which leads to the removal of the extra electron on the phosphorus atom. This extra electron is then attracted downwards to the empty hole in the boron atom. Over time, this movement increases, generating a negative charge on the N-type layer and a positive charge on the P-type layer. This causes an electric field from the N-type layer to the P-type layer and a difference in potential, producing a voltage. During our research, we found 2 feasible methods to construct a solar cell. The first method involved titanium dioxide, mineralized water, berry juice, and conductive plates. First, we had to take titanium dioxide and pour demineralized water into it. Then we had to stir it for a while until it became a gooey-like substance, which is shown in the left photo. Then we had to take blueberries and put it in a juicer to make blueberry juice, which is shown in the middle photo. Even though it looks disgusting, it is still blueberry juice. Then we put the titanium dioxide goo onto a conductive plate and put it on a hot plate for about an hour or 2 at a high temperature until it dried up. Unfortunately, it dried a little too much as it became super flaky. As soon as we moved it, the titanium dioxide coating just fell off, which is the opposite of what we wanted. After that, we were actually supposed to put it into the berry juice, which would produce an electrical current, supposedly. However, we never got to that step despite multiple trials, as it always kept on flaking off. Thus, we had to scrap this method and move to the other one. Our second construction method involved a copper board, Sharpie, ferric chloride, and silicon paste, as well as some soldering. First, we took the copper board and worked it up with the Sharpie in accordance to a video we used to construct the solar cell. After that, we put it into the copper etchant for about 10 minutes. The copper etchant is the ferric chloride, and we took it out and wiped it down with some alcohol. After the copper etchant, it became really yellow and some of the Sharpie fell off. Even though some of the Sharpie came off, that's like it was supposed to do, the yellow part of it was not shown in the video, so we suspected something wrong with it, but we just followed their instructions and hope for the best in this case. After that, we had to solder along the Sharpie markings, which was a very tedious process, as even though the soldering is supposed to be kind of easy, as we were kind of experienced with it, it just did not want to be attached to the Sharpie. After that, we rubbed a generous amount of silicone paste onto the board and let it sit on a hot plate for 6 hours at 60 degrees Celsius. The end result is shown on the right, and it didn't produce any voltage at all, even though we put it in the sun. In fact, it will initially show a voltage of 6 volts in the dark, but I think that was just the multimeter being funky. Thus, Timmy is dead, and he's quite sad about it. What we've learned from this project is to never trust tentative or arbitrary instructions and find clear cut ones. So that will be a note for the future self. And another thing is that we should have, uh, I think we should have just made or used like ready-made solar cells and connected them into an array for a solar panel, as that would have been a much more efficient use over time, and we still would have learned E&M concepts from it. However, we had a great time, and thank you for listening to our presentation.